Welcome back to Lesson 6, Adding Members, Part 2 of the SDS2 Getting Started series. We will now continue with adding members into the model in SDS2. Create a saved isometric view. An isometric view is very useful when you're opening up the project, especially for other disciplines that are looking at the model in SDS2. Now, you can easily do as I did here earlier and simply use the rotate option, rotate into an isometric position, and then go ahead and save the view as. Another option would be go ahead, I'm going to open the view back into my second floor. If I want a true, accurate 45-degree view, I can go to this isometric view. You'll notice that there's these options up in the binding box in the top. If I use my scroll wheel, I can rotate that model. I'm just going to go ahead and accept this. Then I'm going to unzoom to the extents of the steel, file, use the save as view, and call this view ISO. Go ahead and open up my roof view, and it's time to go ahead and add some beams. Now we have this feature called depth check, of course, that allows you to see in and out of the screen. We're going to cover this further on down the road. For now, if I look at this, I am in plan view at elevation 126. I cannot see the beams below. I'm going to turn off the depth check, and now we can see the members below. Now, if I were to come back in here and add in a beam, the system will remember the last beam that was used. So, for example, if I come in here, we look at this, I locate 2 points, and it's going to remember the last input beam, which happened to be a 12 by 35. Now, interesting thing about SDS2 is if I come in, double click on this previous member, notice the elevation is at 114.6. If I go ahead and I hit OK on this, and then I come in to add a beam, even though I'm at elevation 126.0, and I go ahead and use intersection construction line, which puts me on this working plane. If I were to come and hit repeat, the system would say the member overlaps, because again in SDS2 it remembers all the data, including the elevation, the working point, orientation, all that section data. It's remembered, and therefore the system says, hey, I can't put this back on at 114.6. So what I'm going to do here is, in this particular member, instead of repeating it at 126.0, I'm going to add it back in. Notice it picked up all that previous data. It's no longer the W12. And now I'm going to come over here and I'm going to repeat the member again right here. So now when I look at this, we can see that we have those two members that are added up here on the top of the column. Undo view to get back to that elevation 126.0. Turn on that depth check again. This way I will not see all those beams at elevation 114.6. And now I'm going to add in a sloping beam between grids A and B on axis 2. Now when I use the point locator intersection construction line, it snaps to the current working plane, which happens to be at elevation 126.0. So I'm going to go ahead and locate that first point. Now when I go to that second point here, I am going to use the exact point, and what exact point does is it brings you to the center of a hole, or the closest end to the selection point of that particular member. In this case, it's the column, brings me up to 126.9.5. If I were to use intersection construction line for this point, we would see that I would snap to the working plane, which is at 126.0. For more information on what each of these point locators will do, go to your locate, go into your help, and this will give you a full description about these point locators and how they function. Okay, so I'm going to use again exact point, which means it's going to go to the top of this column at 126.9.5. Going to go ahead and select locate and add in the W16 by 26 member. Okay, now if I were to go ahead and do a repeat right here, what would happen is, even if I use the exact point, remember, repeat remembers the left end elevation and the right end elevation, which means that even though it's showing me 126.9.5, the actual elevation for this piece would still be the same as that previous beam at 126.0. So we're going to go ahead, instead of using a repeat, we're going to use exact point, and then I'm going to use exact point again. Notice again, the system remembers the first point locator for the beam that was used last time and the second point locator that was used for the beam last time. There we go. We've added in that next particular member. Now let's go ahead and add in some sloping beams right here. Again, I'm going to use my exact point. Doesn't matter, the top of column's at 126.0. I'm going to put in the first point, second point, that's good. This happens to be a 16 by 26. I can't repeat it here because I'm sloping from grid line 2 down to grid line 1, but I can repeat this member here, so I'm going to repeat, 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 and that will complete adding in these sloping members right here. I'm going to clear the add beam command by hitting escape. Of course, this brings us back to our select items mode. Now what I want to discuss is the left end of the member. Whenever you look at a member, you can determine the left end of the member by the system piece mark and the member number. This is one method. Currently, we haven't processed and created solids, so no solids have been created. There's been no connection design and development yet, and there's been no system piece marks assigned to these particular members. Now what if you have what we call display options, which allows you to turn off items hiding the piece marks and the member number? So how do you know what the left end of that member is? Whenever you hover on top of a member, a target will be placed only at the left end of that particular member. Now let's talk about adding in members and the left end. I'm going to go ahead using my beam command as an example, and I'm going to add in a member going from left to right. As I add in this member left to right or bottom to top, you'll notice that the left end, of course, is indicated over here where the member number is, and eventually the system piece mark. So what happens if I come in here and I add a member going the opposite direction from right to left or top to bottom? With SDS2, the system will automatically adjust the left end to the standard drawing convention where the left end of the member is going to be, which of course would be the left side or the bottom in case of this example when we're in plan view. So when I go in to edit this member, I'm going to go ahead and look at this, and we can see that this is going to be my left end data, this is going to be my right end data, and this is going to be my left end where the target is placed. I mentioned earlier that SDS2 does not have an undo command. We only have an undo view command, which allows you to scroll back through buffered views, and we do have what is called an undelete command. I'm going to go ahead and select these members right now. Using my keyboard, I'm going to select delete to remove them. From my model drop down, as I go down here into my member, you'll see that we have three undeletes. You have the undelete, visual undelete, and quick undelete. If you have not closed your window and you deleted some members, you can simply hit the quick undelete and it'll bring those members back. Once again, when I delete these, I'm going to go up to my model again, go down to my member drop down. Let's go ahead and tear this off. Now, what does visual undelete do? Visual undelete, this is used, let's say you've closed your modeling window, you went home and you came back the next day. With SDS2, you can undelete until, of course, if you remove those deleted members from something called utility functions, which I'll discuss a little bit later. So if I use this visual undelete, it shows me all these members, and I can select which ones I want to go ahead, right click, to bring back. As you can see, I bring back that other member. Then of course the last one is the undelete, which allows you to go through and you can select a individual member to bring back. Now I don't have any system piece marks because we haven't processed yet, but we can see these different members that are stored that have been deleted. Let's go ahead and finish off by deleting that particular member. Now I'm going to add in a joist. Start off by opening up that member add command, going down to my joist. Now the thing about SDS2, when you're adding in a joist, you need to make sure that you are adding the joist at the top of the joist. We're not adding it at the underside of the shoe, and we're not adding it at the bottom of the joist. Currently SDS2 is restricted to adding a joist at the top end. We do not detail joists. That's up to the joist manufacturer. So when we put in a joist, even after process, we are not going to have any solid material unless you run a parametric that'll place in solids for the chords and for the diagonals. but these are of course just a representation. Or if we bring in what's called a BIM joist, which will be the accurate representation of the joist from the joist manufacturer. So I'm going to go ahead and add in my joist using intersection construction line. I'm going to type in here 24K4 joists. We can see our elevation is at the top of my joist was at 126.0. Now, if this joist were sitting on top of a beam and I would want to have it bolted, I would need to change this to a plane end, and then in my connection spec we would change this to bolted and bolted for the right and left end. Now, in this particular joist, I want to have a seat created in the actual web of the column. I would also like to come in here and you can change it to a plate, unstiffened angle, stiffened angle, or a T. Let's go ahead and grab a unstiffened angle, see what happens. Next, for the bottom chord, this is a tie joist, I want to use a plate stabilizing material. Go ahead and hit OK and return to get out of the joist add command.